Today in class, we'll be doing Lesson 12, the greatest common factor. The greatest common factor of two whole numbers, a and b, written GCF of a and b, is the greatest whole number, which is a factor of both a and b. There are two different methods that you can use to calculate the greatest common factor, the list method and the ladder method. I'm going to go through each example with you, okay? Please take notes on whatever I do in the video. Okay, the first one, we're going to find the greatest common factor of 12 and 18. A factor is something multiplied by something else to get a product. So I'm going to actually do a way called the list method that you've probably seen in elementary school. I always start with the number 1 because I know 1 is a factor of all numbers. 1 times 12 is 12. 1 and 12 are factors of 12. Then I go to 2. 2 does fit inside 12. 2 times 6. These are both factors of 12. Then I go to 3. 3 times 4 does indeed give me 12. And then I go to 4, and it's already in my list, so I know I should stop. Okay, now I'm going to list all of the factors of 18. You're going to start with 1 again. 1 times 18. I'm going to draw my rainbow this way this time so I don't mess up all of my work. I'm going to go to 2. I know 2 times 9 gives me 18. I'm going to go to 3. 3 times 6 gives me 18. I'm sorry, I forgot to draw my rainbow here. 4 doesn't go into 18. 5 doesn't go into 18. And then I go to 6, and it's already in my list. So now I look at the ones they have in common. They both have 1s. They both have 2s. They both have 3s, and they both have 6s. So the GCF, or greatest common factor, is 6. I like the list method. If you're good at your facts, the list method probably would be a very good one with you, but you're in middle school now, and my job is to teach you shortcuts and easier ways to get your math done. So I'm going to introduce you and strongly encourage you to use the ladder method. Okay, the ladder method's very easy. You put the two numbers that you're trying to find the GCF of in what I call an upside down division symbol. Okay, and then you look at them and you say, okay, what numbers can 12 and 18 both be divided by? I'm just going to say start small. They're both even, so I know 2 goes into them. 12 divided by 2 is 6, and 18 divided by 2 is 9. So now I have 6 and 9, okay? And 6 and 9 can still be divided by something. I'm going to divide them both by 3. 6 divided by 3 is 2. 9 divided by 3 is 3, okay? And then I look at 2 and 3, and 2 and 3 only have one common factor. The only thing that can go into both of them is 1. Okay, so to find the GCF, I'm going to tell you this upside down bar looks like an F. So you circle the stuff on the outside of the F, and 3 times 2 is 6. So the GCF is also 6. So that's another way you could do this problem. In example 2, it asks us to find the greatest common factor of 20 and 24. I am going to do the list method one more time just so you have a backup plan, but it's not one that I would encourage you to use because sometimes my students miss facts. Sometimes they don't know the facts of all the numbers. So I think that the ladder method is going to be my favorite choice. But let's just do the list method one more time so you have a backup plan. 20, you start with 1. 1 times 20 gives you 20. You go to 2. 2 times 10 gives you 20. You go to 3. It doesn't fit inside. You go to 4. 4 times 5. You go to 5, and 5's already in their list. So these are all the factors or things that fit inside 20. Now I'm going to do the factors of 24. Okay, I'm going to start with 1. 1 times 24. 2. 2 times 12. 3. 3 times 8. Go to 4. 4 times 6. I go to 5, nothing, 5 doesn't fit inside 24, and I go to 6, and it's already in my list. So the ones they have in common, they have 1, 2, 4. And that's it. So the greatest common factor of 20 and 24 is going to be 4. So let me show you how easy this is in the ladder method. And I'm going to do the ladder method 2 times. Okay, if you want to take them both down, you can. But I'm going to show you that no matter what you pick to divide 20 and 24 by, you'll always end up with the same greatest common factor. It's kind of cool. Looking at these two, I'm going to start small again. I'm going to say 2 goes into both of them. 20 divided by 2 is 10. 24 divided by 2 is 12. Okay. Now I'm going to divide these by 2 again. 10 divided by 2 is 5. 12 divided by 2 is 6. And 5 and 6, the only thing they can be divided by is 1. So I look at this crazy thing that looks like an upside down F, and you circle all of the things on the side. Sometimes you might have 1, sometimes you might have 5, okay, and you put a multiplication sign in between them. So 2 times 2 gives you a GCF of 4. Well, what if we had just divided both of them by 4 to begin with? 20 divided by 4, 5, 24 divided by 4, 6. Circle the stuff on the side. There's nothing to multiply here, so the GCF would just be 4. Okay, just wanted to make sure I pointed out that comparison. Okay, so now I'm going to go down to example 3. Ooh, I love example 3. And I'll put example 4 up too. And I'm actually going to cross out the list method, and I'd like you to too. Let's focus on the ladder method today to help us find the greatest common factor. So I'm going to put 19 and 21 in the ladder method, okay? And right away, I'm confident that 19 and 21 cannot be divided by the same number. They do not have any common factors. The only thing that goes into both of them is going to be 1, okay? When you cannot divide the two numbers by any common number, the greatest common factor is always going to be 1. So the GCF is 1. Example 4, ooh, I love 3 numbers, 45, 60, and 75, okay? Let's write those down. All 3 of these can be divided by 5. 45 divided by 5 is 9. 60 divided by 5, 12. 75 divided by 5 is 15, okay? Now I'm going to say, okay, these can all be divided again. All 3 of these numbers can now be divided by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. 15 divided by 3 is 5, okay? So again, this cool thing helps you remember the GCF is just the stuff on the side here. Okay, and I circle it and I put a dot to remind myself that I have to multiply to find the greatest common factor. The greatest common factor of 45, 60, and 75 is 15, okay? If I had done the list method with these numbers, it would have taken me forever, okay? That's why I'm strongly encouraging you to use this new method, okay? In your video now, just to make sure that you and I was going to have you try this one on your own, but I changed my mind. This one's a tricky one, so let me do this one with you too, and then I'll send you to Educanon, okay? Example 5. The PTA is making fruit baskets to sell at their winter fundraiser. If they have 17 apples and 51 pears, what is the greatest, ooh, that's giving us a clue that we need to do the GCF, number of fruit baskets that they can sell if there is to be the same amount of apples in each basket and the same amount of pears in each basket? Oh, this one is so tricky because I think looking at it, most students say, oh, 17 and 51, those are odd numbers, they're prime, nothing can go into them but 1. When you're doing a problem like this, we will let you use a calculator, I believe, on the next exam. Or you could really even do this by hand. I'm going to use a calculator for ease right now. You should always see if you can multiply this number by anything to get this number. So I'm actually going to divide to figure that out. 51 divided by 17. Ooh, it's 3. That means that both of these numbers can be divided by 17. 17 divided by 17 is 1, and 51 divided by 17 is 3. So the greatest number of baskets here is going to be 17, or a GCF of 17. Those are tricky, but always double check that they can be divided by the smaller odd looking number, okay, because that will really help you. One thing I also wanted to point out is that with this word problem, I labeled the number in my I labeled the numbers in my ladder method. You know how I feel about labeling your data. It's so important. And the last thing I just want to tell you, okay, there could be an additional question in your EduCanon today that says, okay, we can have 17 baskets, okay? The question might say, how many apples are going to go in every basket? All you have to do is look down. There's going to be 1 apple in each basket, because 17 apples divided by 17 baskets is 1 apple. Okay? Another thing, how many pears would go in each of the 17 baskets? Well, 51 pears divided by 17 baskets is going to give you 3 pears in each basket. And if you look down, it says 3. But you always divide these numbers by the GCF to figure out how much is inside, okay? You can go to your EduCanon now and practice what you've learned today. There is homework on Lesson 12 in your Google Classroom for you to do tonight. Have a great day.